So in this lecture I will talk about Clavish Gordon coefficients. They are like transformation bases. I will discuss that how these CG coefficients, means these in short known as CG coefficients, so I will talk about that how these CG coefficients are just like transformation between bases. So as I talked about in earlier lecture, that there is a need to find transformation that connects the bases J1, J2, M1, M2 and Jm, right? We need a transformation that connects these two, and this can be written as basically J1, J2, J and M, right? It can be written in this way as I talked about earlier. So for this, let us proceed as follows. Since let us consider Jm, and this Jm is equal to Jm, and if I multiply by 1 with this, right? So let me talk about this one, that how this help us to connect the things. Since I know from the completeness condition that the completeness condition states that this is M1, this is summation over M2, and this is J1, J2, M1, M2, this, and J1, J2, M1, M2, and this is nothing but this is equal to 1. This is the completeness condition. So that means now if in place of this 1 I will write down this whole thing, then I can write down this equation as Jm. It can be written as summation over M1 summation over M2 J1 J2. This is M1 M2 and now it's J1 J2 M1 M2, sorry, and this is basically like this, right? So this is from the completeness condition as I stated here. Let me simplify it. This can be written as summation over M2 M1 M2, and this can be written as J1 J2 M1 M2, and this is J1 J2 M1 M2, and this is Jm, right? I write down these collectively, and I write down this here or here, it doesn't matter. So it is Jm, it is M1 M2, and it is J1 J2, it is M1 M2, right? And this Jm, and this I have written here. So that means this J1 J2, this is M1 M2, Now if I try to look at this equation and I put it like this, or not like this, but if I try to compare the things, so that means this equation basically connects these two. This equation will try to connect these two, and this is like a transformation matrix. That means if I use this as transformation matrix, and this transformation matrix when acts over this state vector, the resultant will be this vector, and this vector is nothing but it is j1, j2 and jm, right? So that means this is a transformation matrix that connects these two. Also another thing that this transformation matrix, basically this transformation matrix is a unitary matrix, right? J1, J2, M1, M2, Jm is unitary matrix, right? Now sorry, and this is known as this transformation matrix is help us to write down the CG coefficients, or and is known as CG coefficients or Clebsch Gordon coefficients. Or in short, CG coefficients. That means now the problem of angular momentum addition reduces to find the CG coefficients, that is J1, J2, M1, M2, Jm. That's what we require here, right? And these coefficients are taken to be real just by convention, and therefore we can write as J1, J2, M1, M2, Jm is equal to Jm, J1, J2, M1, M2, right? And let us talk about some relating properties. The orthonormalization condition for CG coefficients can be written as orthonormalization condition for CG coefficients can be written as summation over m1 m2 j prime m prime j1 j2 m1 m2, and it is j1 j2 m1 m2 jm, and it can be written as j prime j and delta m prime m. Since CG coefficients are real, so we can write it as like this. This is summation over m1 m2. It is j1 j2 m1 m2 j prime m prime, and here it will remain as it is j1 j2 m1 m2, and it is jm, right, and is equal to delta j prime j and delta m prime m, and which leads to the following, that m1 m2 j1 j2 m1 m2. This is a very important equation which we have to keep in mind. This is equal to 1. Here we have used the idea that j1 is equal to j1 prime and m prime is equal to m, right? We have to equivalent, and then these delta function will reduces to 1, this delta function, right? If I use this condition, means if j prime is equal to j and m prime is equal to m. Likewise, we have another equation that's also very important equation. So this is one important equation, and another important equation which I am writing in the similar manner. So likewise, this is one equation, and likewise we have this summation over j and summation over m, and this is j1 j2 m1 prime m2 prime. This jm is into j1 j2 m1 m2, and this is jm. This is equal to delta m1 prime m1 delta m2 prime m2, and this leads to a very important equation, that summation over j and summation over m j1 j2 m1 m2, and it is j and it is m, its square is always equal to 1, right? So that's it. These are the two very important equations which we have to keep in mind. So this is a brief idea of CG coefficient, and in the next lectures I will talk about that how to find out the eigenvalues of j square and jz, and in the next lecture I will talk about that how these CG coefficients can be calculated. So thanks for watching this lecture.